So now that we know how to identify types of reactions, it turns out that all you really need to identify a reaction type are the reactants. You don't even need to know the products of the reaction. You can judge those. So you should understand now how a synthesis reaction looks on here. So a synthesis reaction, you have two things becoming one. So number 6 right here on your sheets, you should have put down this is a synthesis reaction. You have phosphorus and oxygen becoming P2O3. Decomposition reactions are exactly the opposite. They are one thing breaking down into multiples. And here we see one of the metal carbonate rules. So you have calcium carbonate breaking down into calcium oxide and carbon dioxide. So this is one of those specialized reactions. In decomposition, one thing becoming two. Combustion reactions involve a hydrocarbon, which contains carbon and hydrogen, sometimes oxygen. And the plus O2, it tells you that it's burning. If you have paper in front of you right now, that paper is slowly burning. That's why old paper appears to brown over time, because the oxygen is combining. When we actually physically burn it and light something on fire, we're just accelerating that process a little bit. The products of this chemical reaction are always carbon dioxide and water, assuming you have plenty of oxygen to complete the reaction. If there's not, then you'll have this orange dirty flame, and there'll be carbon monoxide and other materials in there. Plus, there's nitrogen in the atmosphere, so there's probably nitrogen being combined on those things. You're probably getting some nitrogen in there. But that's your typical combustion reaction. Single replacement. So single replacement is telling you that there's one element by itself, and then you have a compound. So this is a single replacement reaction. You have the lead by itself. It's more reactive than the iron in this case, and so the lead is going to replace the iron in this type of reaction. Double replacement means you have two compounds. So here's an example of this. I have two compounds on the left, magnesium chloride and lithium carbonate. The magnesium and the lithium will trade positions. Turns out that the magnesium carbonate will form a precipitate, insoluble in water, and then the lithium chloride will be soluble in water, and that's how you would separate those. And lastly, acid-base reactions. So in acid-base reactions, you got to have a hydrogen leading it. Now let's see if I can find an acid-base on this. There might not be an acid-base reaction on this sheet of paper. Let's see here, at least in the typical one. So this is definitely a base, and I am not seeing an acid-base reaction on here. So you probably shouldn't have had any. All right, so our last one on here is that, these are just 5 little categories, but not all chemical reactions fit these categories. I added in a 15 down here. How would you classify this? You've got this potassium. This FeCN6 is either ferrocyanide or ferricyanide. I can't ever remember what the term is. There's 2 different ones. You've got this H2SO4, so that's sulfuric acid. You've got water, and those are all combining to make this potassium sulfate. And we got iron 2 sulfate, and we got ammonium sulfate. So we got 3 sulfate products here. Cyanides are being broken down. Part of the cyanides are going in here to the NH4, obviously, and we're producing carbon monoxide as a byproduct. So we have all kinds of things rearranging. There might be multiple parts of this reaction. I'm not sure exactly what the reaction mechanics are. Because remember, this is overall. I mean, it's possible that 2 of these things react, and then that product of the 2 things reacting reacts with the water. And so there's a bunch of different things going on here. So this one's not easy to classify. You can't just simply give it a label. More complicated type of reaction here. So as long as you got the idea that all you need is the reactants, that makes it fairly easy to predict products, and that's our next major mission here. So predicting chemical products. I give you the reactants. You will predict for me what is going to get made on this. This is what I like about the power of science. Now we have the ability to make predictions here, and that's what I enjoy about a good science, is that you can make predictions and see how well they work. All right, so our first one. Now, in the end, I'm not going to care if you can identify the type or not, because you can't predict these products without knowing what the type of reaction is. But just by looking at this, think about what this is. You've got silver by itself, and you've got copper sulfate. So what you have is an element by itself and a compound. Well, that's a single replacement reaction. And in a single replacement reaction, the lone metal, it's usually a metal, it could be hydrogen, is going to replace copper, and the copper is going to go off by itself. And there's little arrows that I draw. So we're going to end up with copper by itself, just copper atoms, and the silver is going to bond to the sulfate. And now here's the trick to doing this correctly. You've got to write the formulas right. So just writing AgSO4, that's not going to cut it, because that's not quite right. So we got to think about charges. Silver is always a +1. Sulfate is a -2. So the proper formula for silver sulfate is Ag2SO4. And this is a single replacement reaction. And you can't make that prediction without knowing it's a single replacement reaction. You got to know that in order to make the prediction. So the type is kind of redundant. All right, so that's number one. You figure out that it's a single replacement, and you replace the things that it's singular on. We're going to do some random one of these. There's 22 problems on pages 7 and 8 here of the homework packet here. And we'll probably say that we'll grade at least, 18 of them or so, worth 2 points apiece or so. I thought we'd do 2 or 3 samples here. So as we scroll down here, let's find another one that's pretty good that we haven't done. How about 15? So on number 15, what type of reaction is this going to be? Well, you've got H2SO4, you've got NH4OH. One way you can think about it is that you have 2 compounds. So it looks like a double replacement reaction. You also have a compound that leads with a hydrogen and a compound that has an OH on the back. This is an acid-base reaction. So acid-base or double replacement. So double replacement / acid-base. Mechanism is the same. The hydrogen and the ammonium are going to switch positions. So the ammonium, NH4, is going to bond to the sulfate. But we have to write it correctly. Ammonium is a +1, and sulfate is a -2. So we got to do our crisscrosses properly here. So the ammonium gets wrapped in parentheses, and there's a 2 outside of there. That's ammonium sulfate. And the hydrogen replaces the ammonium. It bonds with the OH groups, and hydrogen and OHs make water, HOH. You can write it as HOH, you can write it as H2O, however you see fit. Acid-base reaction or double replacement, we just made ammonium sulfate. I won't do 16 or 17 because you should know that those are the easiest to predict pieces of cake. So we'll scan down here and see if we can find another nice one. Let's do number 11. This is fun. So what can happen on number 11? You've got 2 things on the right. They're just 2 elements. 2 elements are going to do what? Well, they're going to form a compound. The question is though, what compound? So we got 2 things on the left. We're going to make and synthesize one thing on the right, a product. This is a synthesis reaction. But what does it make? Well, you got to kind of know what the reaction conditions are in order to make that prediction. So there isn't just one right answer to number 11. You could go with standard oxidation state. So normally when oxygen combines, it's a -2. That means the nitrogen has to be a positive version. So it might be something like a +5. Not sure what its common positive charge is, but I'm thinking +5. I could be wrong. So you could think about that. Or, in all honesty, you could just start thinking about compounds you may have seen before. So one possible product is we could get nitrogen oxide or nitrogen dioxide. Or we could get nitrogen, let's say dinitrogen dioxide. Or N2O3. All those are possibilities. As long as you can write them down and eventually balance them, you shouldn't have a problem with it. So all kinds of answers here on number 11, you kind of got to know what's happening there. So NO, NO2, N2O2, N2O, N2O3. There's all kinds of different things. Nitrogen and oxygen can form all kinds of different compounds, depending on the situation. Obviously, the simpler the better. So NO, NO2 are probably your best answers. But again, there's all kinds of these. All right, so I've done number 1. I've done number 11. I've done number 15. That should leave you now with 19 to go. Is that right? Yeah, well, let's do one more. Let's do a 4th. So somebody think of a number. All right, let's attack number 9. I heard somebody thinking about that. All right, so what kind of reaction is number 9? You've got 2 compounds on the left. Lithium and cobalt are going to switch positions. This is a double replacement reaction. DR, double replacement. So what's going to happen in a double replacement reaction? The lithium and the cobalt are going to switch. I usually draw it like this. So the cobalt is going to bond to the bromine. So CO. The bromine is a -1 charge. We have to figure out what the charge of cobalt is. Well, based on COSO3, If SO3 is a -2 and there's 2 of them, this cobalt must be a +4. So the correct formula, the cobalt bromide, is COBr4. You got to write your formulas right. So cobalt bromide, or cobalt-4 bromide, is being made, and the lithium is bonding to the sulfite. Lithium is always a +1. Sulfite is a -2, so I need 2 lithiums to balance that off. COBr4 and Li2SO4. Now, in a chemical reaction, if this were to actually happen, one of these would have to be a precipitate that we could actually capture in a filter, and the other one would go away. Otherwise, if there's not a precipitate, there's actually no reaction that happens. We'll talk about how you know reactions are happening. So up here we had a single replacement reaction, the silver replacing the copper. Silver's a +1, sulfate's a -2. Got to write the formula right. That's the tricky part to these. That's why they're always worth 2 points. You get 2 points for making the switches right. You get 2 points for writing the formulas right. Down here we had a double replacement reaction. The cobalt was a +4 on the left. It's going to be a +4 on the right. We're not going to deal with problems where the charges change from left to right. That's a more complicated type of balance, and we're going to stick with our general forms here. And then we got lithium as a +1, sulfite is a -2, and I just realized I made a mistake. I'm sure a lot of people were yelling at me and I couldn't hear you because this is recorded. That was actually sulfite, SO3. Number 11 is a synthesis reaction. A lot of synthesis reactions, there's only 1 or 2 products you can make. For instance, where's the... there's one that involves hydrogen and oxygen on here, I thought. Yeah, here it is, number 3. There's only 2 products that I know of that hydrogen and oxygen make, and so it depends on the situation that you're in. There's probably only really one good answer there. And then number 15, the hydrogen and the ammonium switched positions. And I didn't show the ammonium switching, so I'll do that. And so I like to show, the ammonia is going to come over here, and it's going to trade positions and bond with the sulfate. So then we get ammonium bonding to the sulfate, and so we get NH4, which is a +1 charge, so we need 2 of them. So that's where this 2 comes from. And then sulfate is a -2. And then the hydrogen bonds with the OHs, and you get water being made. This is what makes it an acid-base reaction. All right, so I didn't show you a combustion reaction. Combustion reactions are fairly easy. They always make the same 2 products every time. I didn't show you a decomposition reaction, but look at number 22. What are the possible products that are going to be coming off of this? And there must have been another one I didn't show you on here because there's 6 types of reactions, and I didn't know there's only... Okay, yeah, that's it. I found them all. When you're writing these, don't forget about the magnificent 7 gases. Your O2, your H2, your N2, your Br2, etc. Chlorine, fluorine. Forgot to put the 2 on there. If you got those gases, then you got to make sure that you write those gases appropriately on both sides. All right, if you have any questions, I'm sure I'll be live and online to help you with this. You'll have 2 days to work on this, so you can do some one day, some the other. You've got 18 of these now to do. They'll be worth 2 points apiece, so this is out of 36. Good luck. If you have questions, let me know.